Hi, I'm Gustavo Navarro.
And I'm Jesus Ayala.
If you can measure it, you can improve it. And this has a multi-million-dollar impact in an industrial plant, as your goal is to maintain top production and to reduce energy and maintenance costs.
The ALERT suite of solutions continuously monitor your rotating machines and enables you to get not only overall vibration and temperature data, but also to obtain FFT and wheel and automatically when a machine enters into alarm.
So today we're going to show you how to obtain an FFT with the ALERT 2 sensor and how this tool helps us interpret what happens in a centrifugal pump. Here we have two pumps connected in parallel, operated by Pump Smart controllers.
At this time, Pump 2 is operating at 90% of the BEP. Therefore, its vibration level at the main pass frequency should be relatively low. In this case, the speed of rotation is 3,500 RPM, and the impeller has 4 vanes. Therefore, the vane pass frequency is 14,000 CPM. With the ALERT app, we select the sensor. We touch in the menu icon and the advanced tools, and we order the FFT.
The app asks the sensor to measure the vibration for 20 seconds. Then the sensor itself performs the FFT algorithm. When finished, it sends the file with the time waveform and the FFT spectrum to the tablet. I want to emphasize that this is one of the two ways to obtain the FFT. Probably the most useful is the automatic mode, when ALERT performs it every time it detects an alarm condition. That is to say, the moment we have an upset condition that warrants an alarm, the sensor takes a picture of the problem.
The app gets the FFT, which shows relatively low amplitudes, up to 1.3 millimeters per second. We note that at the vane pass frequency, the amplitude is 0.5 millimeters per second. On the other hand, there is always some level of imbalance that can be seen at the speed of rotation. But in this video, we want to focus on the hydraulic issues.
Let's now look at the spectrum of the operation with the block discharge. We close the discharge valve and take a new spectrum. Now the pump is running at 0% of BEP. Now we observe in the FFT that the amplitude at the vane pass frequency has increased from 0.05 to 0.08 millimeters per second. This can better be analyzed through the AI platform, which shows the information of all the sensors in a plant in a single asset management system. By selecting two FFTs, one close to the BEP and the other at shutoff, we notice the amplitude has increased from 0.05 to 0.08 millimeters per second, whereas the amplitude at the speed of rotation is preserved. This is something we should expect, as it corresponds to an inertial imbalance, which is not affected by hydraulic conditions.
Let's now look at the spectrum when cavitation takes place in the suction line. Cavitation happens when the pump pressure in the pipe or inside the pump falls below the vapor pressure of the liquid. So it begins to vaporize, forming bubbles that then implode upon reaching a high pressure area inside the pump, which generates impacts on the impeller and the casing in a chaotic manner. One would expect to find amplitude at different frequency, typically higher than the vane pass frequency. Indeed, the FFT we take shows a profile similar to a mountain range between 15,000 and 33,000 CPMs, in this case with amplitude of up to 0.04 millimeters per second.
We want to show the same operating condition close to the BEP, which we saw at the beginning, but this time at 2460 RPM. Jesus asked for an FFT, and let's see what we get now with the aid from the ALERT platform. We see that the first peak has shifted from 3500 to 2460 CPM, and the peak in the vane path frequency went from 14,000 to 9840 CPM, something logical, maintaining linearity with the speed of rotation. However, something more interesting is what happens with the amplitude, which is reduced with the square of the speed.
Let's see a comparison between these two FFTs taken in previous experiments. At the speed of rotation, the amplitude went from 1.3 to 0.06 millimeters per second. So the quadratic relationship between the amplitude is then checked. I want to stress here that vibration has a decisive impact on a machine's life. The use of variable speed drives in a rotary machines is something that should always be evaluated.
Vibration analysis is a large body of knowledge, and we have barely touched the surface with this video. The ALERT allows us to make this analysis with a minimum investment, wirelessly and with total ease, keeping the staff safe while collecting the data of the equipment. In addition, where Bluetooth gateways, the ALERT solution is transformed into a true remote continuous monitoring system, in combination with the ALERT Asset Intelligence platform.
Thank you very much for watching this video.
For more information, you can go to i-alert.com or click on the links in the description of this video.